Today I am making it little more easy because we have just 1.5 hour session, and I just want to make it little easy and simple. And what we can do is, I will try to complete this in 1 hour, okay, and then you try to execute the previous programs for some time, not I am not giving you full time for that, okay, for some time you can execute and we can discuss. It is like the open discussion, right? And what are the doubts? If you have any doubts or anything, we can discuss about our concepts, right? So in the last sessions we started with the vision concepts. All of our completed 3 sessions, we discussed about the vision concepts. Like initially we started, our concepts are started from CNN, vision concepts, CNN simple classification, and then auto encoders, that is for generation of the images, variational auto encoders by taking the variance and the randomness with the random, and then we completed the GAN concept, that is completely from random we are generating the images, and then we try to combine the text based data with the image data, meaning that searching, simply we can say that searching at the application, what we discussed is searching the images based on the text. We have done that part, but the originally clip, in the last session we discussed about the clip. What is the purpose of clip? What is the purpose of clip? Only to search the images? Caption. Caption means if you give some caption, the related images will be given. Is it right? It is not image captioning. Please understand that this is not the image captioning. We are not doing the image captioning. In the yesterday's example, we have not done the image captioning. For the given text, the related images are displayed, right? And actually the concept is, it is a general concept that can be used for both purposes. That can be used in both purposes, meaning that we can get the filter, meaning that we can filter the images based on the given text and we can display them, and before displaying the images, actually what is the architecture? If you recollect the architecture of the clip, it is having 2 encoders. One is the text encoder and second one is image encoder. Am I correct or wrong? It is having 2 encoders for training. For training it is having 2 encoders. Now for classification or to filter also we need 2 encoders. There are 2 steps actually. One is the training, second one is the first step is the training, second is the classification by using 0 shot. Okay, so in the first phase we are using encoders, 2 encoders. In the second phase also we are using 2 encoders, because in the second phase we have to give the sentence and then it has to filter the images which are satisfying this sentence, right? So this is the basic concept of the clip. Now my idea is different. I don't want that. Already images are available, my images are already there. Whatever I am filtering, I am just filtering the images. I am not generating the images in that. I am not generating images. I am just filtering. How we are filtering is, we are converting the image and text into the intermediate codes, that is the vector, representation vector or latent space, whatever it is, and then we are taking that for either filtering or for some any other purpose. Now we will see the application of clip in different way. Yesterday we have seen the filtering the images. We have filtered the images from number of images, we have filtered based on the given text. It is like our Google search. In the Google search, if you give the sentence related to that, the images will be displayed. In the similar way, we are getting the images, related images in the given set of images, not from the global. Not from the global, in the given set of images what are related. I have given the small example also. We can take the campus pictures and we can give the captions, we can give the training, we can give that to the training phase, and then we can type one sentence like the class is going on. If you give that sentence, whatever are the pictures related to the class which is going on, those pictures will be displayed. So that is what we have done yesterday. Today I want to generate the images. I want to generate the images, and clip is doing some part of the analysis, and I want to extend that clip service. I want to extend that service. How we can extend that? The key point here is we are having the representation vectors. I am using this word representation vector. We are, or embeddings, we can call it as the embeddings. Embeddings are representation vector. If you are using for images, we will call it as the representation vector. If you are using the text, we are calling that as the embeddings. And then now we have to, this is the main part. Once if you encode it, that part you can take and you can do different things. Now in this, my intention is I want to generate the images based on my sentence. Yesterday we have filtered the images, existing images based on my sentence. I have to give some text and it will filter. Now I want to give the sentence, it has to generate the new images based on my sentence. Got my point? Both are different. It is not the same concept. In the previous case, we are giving the sentence, getting the filtered images of which are related to this sentence. In another level is, today's level is, I want to give the sentence and based on that sentence it has to generate the new images. Clear? In the generation of the new images, sometimes you may get the irrelevant images also, because there is no direction. Directly we are just giving the sentence and I am expecting this. For that, what we can use, that is Dall-E, right? Dall-E 2. Dall-E 2. Okay, 2 is version. What is the difference? There is a small difference between these two, Dall-E and Dall-E 2. Here, in the Dall-E concept, what is this actually? Let us go through this. Creating the high quality images, I am just reading. Creating high quality images from the textual descriptions, and how we can do that? That is a challenging task in the AI. If you use only encoders, auto encoders and all, we can generate the images by using another image, that's it. Now this is the challenging task to generate the image from the text, and Dall-E, it is giving the way to generate the new images based on the given text or description. You can give the description, you will get the image, right? And how it is working? The base concept of this image generation, Dall-E 2, it is using the diffusion model. Diffusion model means, what is the diffusion model? I will give you a small example for this. General example I am giving you. How many of you played in the sand, with sand in your childhood? You played with sand, right? Others? No. No. Infections. We have to play. So if you play with sand, I think you may get this concept. See, we can put the sand on the floor, and there you can adjust something and you can get some object. Is it possible or not? Did you do that? Put the sand on the floor and you can adjust something, the sand, so that you can get some images, some smileys and all. I think everyone played. With flour also, with rice flour also you can do that. While doing chapati also you can do that. Right? You may play that. This is the same concept. Meaning that take the noise and generate the image. Of course, the Dall is also based on the encoder-decoder architecture. And diffusion model, what is the diffusion model? Already we have the GAN, okay, and VAE. They are generating images, but we are not getting in the proper way. There are some limitations. What are the limitations is, in the VAE, it is giving some blurred image compared to GAN. GAN is giving clear picture, but there is no direction. There is no direction for GAN. It may give legs here, hands here. Legs here and hands here. It may give the GAN generated. There is a possibility, because there is no direction. There is no direction. It is generating from the randomness. So there are some problems in the GAN and VAE. Okay, and diffusion model. The diffusion models, they have designed based on the physics. I am not discussing about those concepts. Even I am not using those words also. So what it is doing is, it will take some image. I am giving you the brief. It will take some image. Step by step, it will add the noise. It will add the noise to that image. After that, again slowly get back the image in the reverse operation, meaning that step by step you are adding the noise and again getting back. In the getting back, in this situation, the model has to train to get back the original image from the added noise. Hope you get. So this process has to be continued number of times, so that we will get the original image. Not only the original image, you can denoise the image and you can improve the quality of the image by using this process. Okay, now you can see that here. Yeah, I think you are seeing that here. This is the original image what I am having. This image, in the first phase, that is the forward noising. In the forward phase, we will add the noise step by step. We will add the noise. In the reverse operation, that is in the backward direction, we will denoise the image. We will denoise the image. How it is performing? The model, if you want to discuss about the model, it is another big concept. Okay. I am not discussing about the concept, in detail about the concept. I am giving the overview of that. So in the first phase, we are going forward by adding the noise. In the second phase, that is in the denoising, into original image. We are coming back to original image. And you can see that here. From noise, we will get the pictures, clear pictures, denoising. Of course, there are so many GIFs are available in your Google. I have also taken from the Google only. You Google search. You can search for that GIF images for denoising or diffusion model. You can search for the diffusion model GIFs. You will get all these pictures. Okay. So from the diffusion model, we can generate the quality pictures. This is what you have to understand. Compared to GAN and VAE, we can get the better quality pictures by using diffusion model. Right? It is also a very big research area, diffusion models. There are so many papers published on this concept. Okay. Now, this is the diffusion model original architecture. See here, we are going through the diffusion process and denoising process. Finally, we will get the regenerated image. Okay. And now, why should we discuss about this? Because this, see here, in the Dall E2 architecture and workflow, I am combining these two. In the Dall E, how it is designed is, it is having 3 parts. It is having 3 parts. First part is clip, by using clip. What is first of all, what should be the input, what should be the output? You should think about that. You should keep it in the mind. What is the input? What is the input? Input is sentence or text. Sentence or text. Some text. And what should be the output? Output should be the image. Sentence to image. If you want to analyze the sentence, we have to use transformers, right? Definitely we have to use the transformers. And in that encoder part, especially encoder part is important. And one more thing, we have to convert this into image. And there is a model available to combine these 2 features. One is text and second one is image, that is clip. So first initially we will pass the given sentence through clip. Okay, what the clip will do? See here, it will analyze the text and it can identify the related images also. Please remember, it can identify the related images. Okay, and second part is a prior neural network. Whatever we are getting from the clip, we have to adjust the weights and we have to generate some basic image features. We have to generate the basic image features that will be done by prior neural network. And next part is decoder. It will generate the final output image. It will generate the final output image. These are the 3 important steps in Dall E. Right? Here, we will go with this clip architecture. You just recap that clip architecture. See here, this is the training phase. In the training phase, we have to give the sentences and images. We have to use the encoders, image encoder and text encoders. We have to generate the representation vector, that we can call it as the embedding vector or embedding matrix. In that, from here, the next phase is we have to classify. We have to give some text and that has to be encoded, and with this encoded embeddings, from these embeddings, it has to identify, please remember this, it has to identify the features of the image. It is not directly identifying the image, it is identifying what are the features related to these features, these embeddings. Whatever the embeddings generated by the encoder of text, It is identifying the similar features of the image. Once if you identify this, from here we have changed the model actually. From here what we have done is, for which image it is satisfying, we are taking that image and we are just displaying it. This is what we have done yesterday. Here what we want to do is, I want these features, whatever the features are there, the embedded features or the encoded features of the images which are related to these embeddings. We will take those features, we will collect those features and keep that aside, okay. And then next step is, see here, in this is the Dall architecture, complete architecture. We discussed about the diffusion model and clip model. We have to combine these two. Clip is to identify the similar images and diffusion model is able to generate the images. If you combine these two, without any direction creation of the picture, instead of that, we will generate the images from some guidance. Instead of creating the picture without guidance, it will create the images with some guidance of filtered pictures. Filtered pictures are features. Hope you understand. Now what it will perform, how it will perform is, see here, I am giving some text. What is the text? At this moment I am not bothering about what is the text I am giving. I am just giving one text. How can we analyze the text? By using some encoder, text encoder. It is the part of the clip. Clip is having two encoders. I will just connect the given text to the clip encoder. See this dotted line. This is the clip. Top one is the clip. Okay. So see here, from here the encoded part will be taken and the embeddings will be generated. From that it can find the features of the images which are having the similar properties. See here, it generated the embeddings. Based on these embeddings, the similar feature images are filtered and those images will be taken, those features are taken. See the arrow marks. The clip objective, from the given text, related images are identified, and from that this vector, these features, whatever the features identified based on these embeddings, they are given to the diffusion model. Diffusion model. Not only the diffusion, actually here there are two types of algorithms to generate the images from the randomness. There are two types of algorithms available. Autoregressive, one is the autoregressive, another one is the diffusion model. Okay, so here you can call this is the autoregressive, meaning that it is just feed forward, and this is the diffusion model. You can call this is the diffusion model. You can use any one of them. Dall 1 is using the old one, that is autoregressive model. Dall 1, first version of Dall, it is using autoregressive model, but the latest version Dall 2, it is using the diffusion model. We are applying the diffusion model on the features extracted. The feature extracted based on the given input embeddings. Hope you understand. What is this actually? Is this the image? Is it the image? What is this? Is it the image? Is it image or not? Is it image? Once if you go through the feed forward, it will not be the image, it is a feature. Please remember that if you apply the convolutional neural network and if you get one at one point it will be the features only. All these are features only. From the features you can connect the dense layer and you can go for the classification, or you can connect the reverse, that is the upsampling and regeneration of the images, that is for regeneration of the images. So here you have to remember, already I am telling that the convolutional layers, they will not classify. Generally we will not use that for the classification. We will use the convolutional network or convolutional layers to extract the features, only the features. Here also the encoder, image encoder, actually here what it is, that the image encoder, the encoded image, we are getting the encoded image here. Which encoded image? Which encoded image? It is not the random. Based on your given text, it is filtered the images, those image features are taken, they are given to here, right? And from here we are applying the diffusion model. What is the diffusion model? Whether it is the image or some data, it will just add the noise. Step by step it is adding the noise and go back, and again feed forward and backward, feed forward and backward, forward and backward. It will be continuously, it will, by using the diffusion model, it will rotate number of times, number of epochs. After completion of those epochs, it will generate some features, it will generate some meaningful features, or the features which can represent the required object. Okay, from here onwards we will add one more decoder. Actually here we are not generating the image, we are just tuning the features. Once if you tune the features, then we can apply the decoder. This decoder is again the diffusion model. We can apply again the diffusion model. Second time we will apply the diffusion model to generate the image from the features. From the features we will generate the image, meaning that we will apply the diffusion two times. Once it is in the inside the Dall architecture, and another one is at the decoder level. Encoder and decoder, we will think that only, we will think about these two only. We are giving the input text, it is encoded, and we are getting the output image by using the decoder. Encoder and decoder, text encoder and image decoder. In between, this is the process what it is doing, meaning that it is using the clip architecture. Why should we use clip architecture? Without clip architecture, can you generate the images or not? Can you generate the images or not? Clip architecture, we can generate. You can skip this part, you can skip this part, but there will not be any guidance. There will not be any guidance. It will take so much of time. You have to give that as the supervised learning. You have to make it as supervised learning, meaning that you have to prepare a data set like a sentence related picture, a sentence related picture, sentence related picture. How many sentences and related pictures you will generate? It is very difficult. And of course, even if you generate it, even if you prepare the data set, very large data set you have to prepare, and if you skip this clip architecture, then it will directly generate the random picture, and because of the back propagation, it will update the weights and it will generate the picture, and it will take much time for training, and it is limited to only some type of images only. And if you use the clip architecture, clip is already pre-trained. Clip is already pre-trained. We are taking the pre-trained architecture. Once if you give the image, Once if you give the text, the related image features are extracted and those images are also available. By taking those features, there is some guidance. Let us say for example, in this, let us say for example, there is a dog in this sentence. If you give some dog in the sentence, simple, I am making it simple. All the dog pictures will be, all dog picture features will be extracted so that it will be easy to generate a dog picture. From the nothing to dog, it is difficult. From some features of dog to generate the dog picture, it is easy. I think you get the point. So by using this concept, here the clip architecture, we are using the clip architecture intelligently in the Dall architecture, so that with the proper guidance of the feature, image features, we are generating the new images. Hope you understand. Right? So, because of this reason, we will get the very high quality features. This is the basic architecture of Dall. The differences between the Dall and Dall 2 is here. See here, this is the architecture. Input text fed to the Dall and it will be given to the encoder part, and the text encoded using clip architecture, and then clip text embeddings that will be converted into clip image embeddings. You can see that here. Text embeddings converted to clip image embeddings via prior autoregressive diffusion model, and then we will go with the decoder part. We are generating the image by using the decoder part, right? And how it will work. Here, this is the architecture. Based on this architecture, we can develop Dall model. We can develop Dall model, but you need very high end machines, GPUs. Okay, high end machines. You require high end machines. Because of that reason, we cannot invest on that. That is very high end features, high end machines you require. So because of that reason, OpenAI, they have already trained the models, and they are giving the models as the paid service. Okay, I think morning also you have done with Chat GPT model, right? You have developed the GPT model, and for that also through Hugging Face you can do that. And from the OpenAI, you have to pay something, and then you will get the credits. You have to add that key to your code so that you can access that model. In the similar way, this is also OpenAI. Same procedure. I think I need not explain that again. Already it was done. So the OpenAI is having all these models available, and Dall-E is available. Dall-E is available. Dall-E 2 is not available. Dall-E is available publicly. Publicly it is available. You can use that architecture. In the GitHub it is available. You can use it and you can generate the images. But Dall-E 2, it is not possible. It is the paid service. Dall-E 2 is the paid service. Okay. Now, let us see some examples. Let us see some examples of Dall generated images. How beautifully it is designing, how beautifully it is generating the images. So see here the architecture. See, while seeing these images, you have to think how it is generating internally, how it is working internally, that you have to work in your brain. Then only you can understand what is Dall-E. Okay, simply to display the sentence and image, it will not give good concept. See here, I am giving this as the input. My input is this. You just read this. I think the last rows also able to see the sentence, right? The last rows, are you able to see this or not? Last row, are you able to see this? See that? A bowl of soup that looks like a monster knitted out of wool. How? You just imagine. You will get some picture inside your brain. Definitely you will get some visuals in your brain. Did you get some visual? Did you get some visual in your brain or not? You get some visual. You just have a look on that. Right? And how you generated? How you generated that? It is exactly mimic the brain. How you generated that image in your brain? Based on these words, you know what is the bowl, what is the soup, how it is looking like, and what is the monster. You can do that. You can know all these words and how those objects are. It is already fitted in your brain. So you are combining all of them and you are generating inside. It is pre-trained. All these words independently, they are pre-trained. Already it is there in your brain. You are just combining the combinations. Clear? So the same thing, it will apply. This will be given to the encoder of the clip. After that will be given to the diffusion model by taking the related images. It will take the bowl images, it will take the soup images and monster images and wool images. It will take all those images and collected and give the features. All these features will be given. From those features, it will generate how it is visible inside your brain. Same, that will be like this. Say this. Did you think like this or not? Your visuals, your inside visuals. Is it looking like this? At least one of them. Is it looking like this? So, the same thing. These are not original images. These are generated images. Please remember that. These are not photographs. These are not photographs. These are generated images. You may think that they are the photos. They are not photographs. They are not taken through camera. They are generated. And another one. See the next one. Now you will get some visual. You just understand that sentence. You will get some visual. And how you are getting that visual, please think. All the words, you know the words. If you don't know the meaning, you can search and you can think about that. And how is the visual? You just imagine the visual. Right? See that. These are also generated by our model. Our model in the sense Dall model. Dall. If I give the sentence, I am getting these images. If you remove this firework, these will be removed. If you remove the snow will be removed. How beautifully it is designing. So we need not have the artists, we need not have the like if you can design a movie by using this. And one more example, see this. I have given this sentence. Directly I have taken from OpenAI only. Did you get the visuals? It will take some time. Why I am making you to think is, in the similar way our Dall is working. If you understand how it is working, you can develop the applications easily. Now did you get? See, for this sentence only we are taking this much of time to get the visuals, and if we give one page of description about a picture, if we give one page description, then how difficult it is to visualize, right? See this. Is it related or not? Is your visual is matching with this or not? No. The entire concept of AI is mimic the brain. Yes, got it? Irregular marble stones, and with gold lines, some gold lines. All these are whatever you have given, all of them are satisfied in those 4 pictures, right? And another example, is it possible? Can you imagine? Right? And other applications also there, not only generation of the pictures, simply generation of the pictures from the text. It is having some more applications through Dall, that is outpainting. Meaning that if you give one picture, it will expand to the next level by changing the background, adding the background, and all this is possible. And I am giving this as the input. I am just giving this as the input. What is there? It is a simple painting, right? And background is just plain background. No, there is no meaning with the plain background. I want to make it meaningful, more meaningful. See this? The background is generated. Now it is meaningful. From the first one, there is no meaning, just a face, that's it. And here it is meaningful. And one more application is also there in painting. Meaning that we have this pool, swimming pool, and I want to give one text also. Please think how it is performing. In this, I am giving one picture and I am giving one instruction also. I am giving one instruction also. If you see the visuals, it is okay. It is just entertaining. But only the thing is, you have to think how it can be processed. The previous case also, how it can be processed. Here, how many inputs are there? How many inputs are there? 2 inputs. One is image. Second is text. So we need 2 encoders. We need 2 encoders. These 2 encoders also can be taken from clip. The clip is having 2 encoders. Am I correct or wrong? We can directly take the clip. The clip is having 2 encoders. Text encoder and image encoder. You can apply those 2 encoders. We can apply them and we can get the similar pictures here, and this has to be processed separately. This has to be processed separately, and this has to be processed separately, and then these two have to be combined. There will be the features for these 2 embeddings, and then we have to combine them. The final output should be perfect. It is not like the imaginary thing. It should look like the real picture. Really we have added that. See this? One concept is there. Augmented reality, some concept is there. Do you know that? Do you know augmented reality? We can add the objects to the existing video or picture. They are having some different algorithms. We can use this for that. We can include this. We are just adding one new item. See here. Flamingo. we are adding that here, right? Remaining is same. Without disturbing the existing picture, we are just adding one more. For this, the architecture, whenever I am showing the example, you have to think about the architecture. If you want to develop the projects properly, whenever you have to think in this way, what is the input? From this input, how can we handle that input into the model? And inside that, what should we do? And finally, what should be the output? What is the flow? That visual should be designed inside your brain so that you can develop the new architecture. Right? And one more, variations also there. If you give one model similar to that, it can be improved and it can give another variation. See here, this is the input what I am giving, and that can be given like this. All these I have taken from the OpenAI only. I am openly telling that I have taken from OpenAI. I have not created. If you want, you can create. How it is reconstructing the images, right? So for this, how it can perform, how it can, the architecture, what you have to change in the architecture in Dall, that you have to think. There are two inputs. This is here only one input and one output. Clear? Is it supervised or unsupervised? Is it supervised or unsupervised? Yes, tell me. Is it supervised or unsupervised? Why it is not supervised? Why it is not unsupervised? Why it is not supervised?
You're not exactly giving labels and asking it to reproduce the prediction. You're asking it to learn the pattern by itself.
Yes. Mean that we are not giving the labels. We are not giving the target. What is the generated image? We don't know. We don't have the generated image. We don't have the output before starting of the training. We are generating, we are just generating. So there is no supervision. Whether it is properly generating or not, there is no supervision. We are just giving the guidelines. You have to go this side, this side, this side. That's it. Finally, you may reach or you may not reach. That is different case. So it is completely unsupervised. All these comes under unsupervised only. All the generative models. The generative models we cannot go for the supervised. In some situations, in the special cases, we have to use some part of the algorithm or model as the supervised. Only some part we have to make it as supervised. Classification, we have to classify. Once if you give the text, that has to be classified. Inside we can use, but overall it is unsupervised. Okay. Now, API, we have some API to use this. Okay. Already I think morning we discussed about the API, how to import the API, OpenAI API, and how can we install. First we have to install pip install OpenAI. I think we have done that. After that, what should we do? Import the required Python libraries. These are the Python libraries that are required, and here the last one to take the image only. To take the image features. Of course, we can change that. We can change that to our regular image libraries. We can change that to our regular image libraries. Okay? And then, how can we set up that OpenAI.API key? We have to give the key. If you pay the amount, then you will get the key. The key has to be given. Okay? And then we have to call the Dall app, Dall API, that is image.create, OpenAI.image.create, and then Here in that we can give the prompt. Prompt is the sentence. The prompt is the sentence, and then we can give the size and all, and then finally we can retrieve the image. One image will be generated and that will be given to your response variable, response object. What is the response object we have taken? That in the response object we will have that, from that we have to generate the image, we have to extract the image. The response is having so many features that includes the image as well as that also, right? And then of course it will use the image to display, will display the image, whatever we have given the text related to that, one image is generated. Hope you understand. You can try with this. Only the thing is you have to generate the key. Once if you generate the key, you can try now also. If you have the key, OpenAI key, you can generate here also. But I think it is little expensive, because they are charging for picture wise, meaning that how many pictures you have generated, based on that it is giving. Based on the pictures, not number of days, number of pictures you are generating, based on that it is developed. Right? Hope you understand. So this is what about the Dall-E, and there are so many vision language models available. First one, we have discussed about the clip and Dall-E. Only two we have discussed. These are the advanced concepts, and we have to work on them. We have to go through the research papers, and we have to go through the step by step all the concepts. We have to get them, and we have to generate generative AI. Hope you understand, right? So how many of you executed the yesterday's program? Can you open the programs? Can you open the programs and execute them? Please do that. Have you done? Did you try with your local machine?
No, I tried on Kaggle, but then the GPU said too much RAM and it crashed.
No, too much RAM is, your laptop will not be crashed.
Kaggle, the interface crashed.
That interface, that is okay,
Yes,
but
my laptop is fine.
yeah, your laptop is safe.
Yes.
So please open that, the program, the yesterday's program. And any questions now? Now it is your time to ask the questions. We have done 4 sessions. In these 4 sessions, if you have any questions, it is a time for you to ask the questions and doubts. Anyone?